Good morning, everyone. Here we go for lecture 2. So we're chapter 16, section 2, mineral exploration and mining. Once again, strongly encourage you to kind of bring up both windows so you have the PowerPoint on one side, video on the other, but however you want to go about it, here we go. Your essential question, 3 methods of subsurface mining. We're going to talk about subsurface, surface mining, etc. and what are 3 of them as we go. All right, first off, just mineral exploration in general. This is the first step. We're looking for ore. This is where if you go into geology, you can make your big bucks. You understand the rock formations, etc., what we expect to find where. So we go to an area and let's say we are looking for sulfur. Well, go to an area that you expect to have it. You drill down and you get some samples and you determine how much sulfur is there, how much coal is there, how much gold, etc. You know, you pull it out and get an idea. 20% of the ore is copper, 30%, 40%, 3%. And if it is high enough percentage and you feel there's enough of it, you check multiple areas in the site, then you decide to open a mine. If you do your job well, the mine makes a lot of money, you get paid handsomely. You think there's stuff down there and you get into digging the mine and you find out it takes too much money to pull it out of the ground, you lose your job as a geologist for the mining company. But anyway, that's what we have to do. We have to determine, is it worthwhile to dig in this area? Otherwise, we don't. The next one, you can take a look at the slide and figure out why they're worried about the dad being under too much pressure. Anyway, let's go ahead and talk about subsurface mining. First off, with subsurface mining, it's got to be 50 meters or more beneath the Earth's surface. If it's less, so a half a football field. If it's less than half a football field, we're not going to bother with subsurface. We're just going to dig down to get to it. But it's a different way. So subsurface, we got to remove the rocks and etc. to get to the underlying minerals in some shape, form, or fashion. Dig down there to get to where the stuff is. So let's look at our first one, room and pillar. And if you will forgive me for a horrible demo here, but limited and stuff. These would be like our pillars. So you have a whole area down here, and we drill down, and we get into this area, and we start carving away the area down here, digging it out. But we leave parts in place. So this whole thing was, destroyed one of my pillars, underground. So we drilled down here, started our hole, and then we started pulling the stuff out. This is the good stuff. This is the salt, the coal. This is typically what we do with these. And then our various tractors can go down here, dig in, pull it out. The surface up here stays supported, just like a roof in a room. You have load supporting beams in a room. If the room's big enough, you have to have columns in the middle. These are pillars. So we do this to extract coal and salt because those things themselves are pretty solid. So this would just be a complete pillar of salt and another pillar of salt. And we're digging all the other salt around it, leaving the room there. So we'll have a series of rooms, and then we will cut out the layers of coal, layers of salt, whatever it is. When we're completely done, remember these things are pure coal, pure salt, which is what we're down here for, and we tend to remove them. So we start by removing the pillars at the back, and we will just chop them down, pull them out by tractor, pull these guys out, and the whole room will collapse, the mine will collapse, and we've taken all the stuff out. We found we don't want to leave nice, big, deep, dark cave mines for little kids and other people to go into, get lost in the cave, possibly cave in on them. So we go ahead and just typically collapse the mines behind ourselves. At least that's the idea. All right, let me get rid of my supplies here. But anyway, room and pillar. The next slide gives you a good idea. You see a huge front-loading tractor down there. The pillars off to the side, they just pull everything out. When we're done, take out the pillars. Next is Longwall Mining. For coal mining, it's been a long time since we've done this guy here, digging down into the pit with his helmet on and chopping out the mine. The old hi-ho, it's off to work we go. Yeah. Okay, so you never saw Snow White and the Seven Dwarfs, but they were miners going after their gems. Well, we've gone to Longwall. In coal, we tend to get these huge seams of coal. Remember, coal is fossil fuels, plants that were crushed, put under the earth, and then when the mountains raised up, this what was once down on the ground pushes up in the mountains, and I get this seam of coal, this big long chunk of it. Well, now we tend to use longwall mining. So we'll have this long seam of coal under the mountain, and we put a machine up a sear. It's just like a huge table saw, and it goes by and it just chunks off lobs off a chunk of the coal, falls onto a treadmill, and the treadmill just carries it on out. Big conveyor belt carries the coal out where other people then process it, throw it on the trucks, etc. So this winds up being more cost efficient. The miners themselves and their equipment are supported by huge hydraulic supports to support the roof from caving in as they pull out the mine. And as they pull it out, they just move everything over. We mine more here, move the whole wall, and then the mine will cave in behind us here. So we're working here, and we're now back up against just caved in rock. And we keep moving until we run out of coal. Then we open a new mine. These things last for a period of years. It depends on how big it is, how effective we are at pulling it out. This would take decades to clear out a mine with a bunch of men going down there with picks, hauling it out of wheelbarrows. Now everything's automated. Take a look at the next slide. You can see this in place. Notice the miners standing there. The ceiling's maybe 8 feet tall, something like that. We have this huge saw just chopping out the coal falling onto the side and running out. Coal tends to look sort of like this. Get us closer to our camera there. A bit of anthracite coal. It just looks like very much a type of rock. It's light, but that's what we're after. This is what our power companies typically use to keep our lights on. All right, solution mining. Now, solution mining is a little different. We talked about the other day when I dissolved the salt, stir it back up, but we dissolve the salt in here. So salt will dissolve in just plain water. So we can pump hot water in there, dissolve the salt, pump it out, and then just dry out or evaporate the water off, boil the water off, however it is we want to go about it. Well, potash, salt, sulfur, these things are all just dissolvable in water. Of course, other things are dissolvable in other chemicals. We don't limit it really to just water. In my container here, this is hydrochloric acid, and I've got a bit of just plain old tin foil. So we take our tin foil, we drop it into the sulfuric acid, and it takes it a little while to get going, but the HCl plus the aluminum will take turn that into hydrogen gas, and it dissolves out the thing. So you can now see the hydrogen gas coming out the top. The tin foil is being dissolved into a solution. Now I could pump this out and remove the materials, but this is solution mining. We simply dissolve out whatever it is that's down there that we're after, pump out the liquid, which holds the solution of something we have, and then go after it. I will set up a virtual lab showing how we can extract copper using this method. Once again, you're responsible for doing one lab this chapter. You could do the virtual lab and or the cookie mining lab. Of course, I highly recommend the cookie mining lab, but you may just want to watch the virtual lab just to get a feel for what's going on. But anyway, the slide says we talked about by injecting with hot water. It could be acid that we're pumping in if we're trying to get rid of something like, or get something like aluminum, and the lab will showcase copper. So it's not always as simple as water. A lot of times with pretty harsh chemicals down there, which is the environmental problem. If that stuff gets out into the real world, we have issues. So next we're going to look at surface mining. So we've talked about a few different ways that we can do subsurface mining. Now remember, 50 meters deep at least, or many times much deeper. But if it's less than 50 meters up, then we basically can just get rid of the soil and the rocks right above it and access it fairly easily. It's a lot easier to access it from the surface instead of going down into a deep dark hole. Less dangerous as well. So close to the surface, a lot of things that we get here are gold, copper, and coal. Of course, we'll talk a little bit later just about rock quarries. We're just literally getting rock. But anyway, the minerals, a lot of ores we're after, all that. Coal, gold, and copper are ones that we tend to do this open pit mining. You look at the next slide, you can see an open pit mine. Yes, it's also just what we call strip mining. We just strip the earth away and go after what's sitting right underneath it. Pretty nasty looking when you're to it. We tend to try and keep these a little bit isolated, not where it's close to lots of people because of the horrific nature of what it looks like when we're done. Remember, if you did the cookie lab, this is where you tried to put the cookie back together and maybe not so good. Anyway, we just mine downward. We start at the top, we take what's here, we dig down another layer, down another layer, down another layer, until we run out of the ore or the gold. We might use explosives. We'll use dynamite, we'll just blast the rock into bits, because what we're having to do is scoop up all the rock, throw it into a truck, carry it back to the factory or the lab, wherever it is, to process it. Now if it's coal, a lot of times coal can be pretty pure, and we'll just take it directly off to wherever it is. But usually we have holding fields of some kind, and then we'll move it by train, by truck, to the power companies or whoever needs it. A lot of things like gold or copper, though, get taken to a leaching pad. Once again, we're going back to chemicals in some shape, form, or fashion, because the ore, it may only be 5% of the actual rock is gold or copper. So we got to extract it. So we tend to pulverize it, dissolve out the copper, the gold, silver, whatever it might be, and then use a chemical aspect or property to get the gold away from the rock. If we're doing coal, this happens a lot up in the Appalachian Mountains, just up north of us, West Virginia, this area. It tends to be in several steps. So we go up to a mountain, and there's soil covering it. So what we will do is we will tend to take all the soil off and move it way over here. And then we'll go to the next area down, which we call the overburden. Overburden is just the rock. Once again, it's the stuff on the top of it. The dirt's pretty easy. We can just bulldoze it out of the way. We got to dig up the big rock. We push it not as far away, and then we expose the coal, and we go to work. And we just dig down into the coal. Drive down into the pit, load up our trucks, drive it out of the way. Another truck goes in, load it up. We just keep going deeper and deeper and deeper until we're out of the coal. So we just remove this entire seam. So we just strip off the top of a mountain, go after the coal, and then comes the fun part. We've got to refill it. We'll look in section 3 about laws and regulations with mining, but when it comes down to it, mines are required to leave the area like they found it or better. Hopefully you did the cookie mine. That's really hard, if not impossible, but it's what they're supposed to do. So, we took the dirt, moved it way over here. We took the overburden, rock, boulder, and moved it to here. And we dug out all the coals. Now we take the rock overburden, throw it back in the pit, and then we push the dirt back over it, and ta-da, it looks like it did. Of course, you know, it's sunken down, maybe not a mountain top, maybe a flat top mountain. But anyway, we put everything back like we found it, minus the coal, the gold, whatever it is we're after. So, Then we get to quarrying. So those are some of the main minerals, economic variety, if you will. Quarrying. This is where we're usually getting things like building materials, rock, marble, granite. Maybe some of you have granite countertops. Well, these will be taken out of a quarry. We just go to an area that is just a huge boulder or mountain of granite. Or we find areas that have huge aspects of quartz, marble, etc. And different areas tend to grow different types of marble. Remember, they're crystals. They were formed thousands and thousands of years ago in an area where it was really hot. The cooler it slows, the smaller the crystals. So things like marble happen over a slow process. Granite, a little bit larger crystals, so it's a slower formation. But anyway, we're just going after this stuff typically for building supplies. We use granite when we make concrete. We're after gypsum, using in the concrete. We may just be using the slabs of rock themselves. Many of our old buildings in places like New York, Boston, etc., they're actually made of rock. But then the sand and the gravel. So if we get nice big rocks, yay. Smaller gravel, fine. We're still using it in building supplies. Maybe we're making driveways, gravel driveways, etc. Or using it to put into concrete to pour out for driveways and pour for buildings, make cinder blocks, what have you. But we go after most of these things in quarries. And what we're after are the aggregates, the sand, the gravel, the crushed rock, etc. We also get clay out of these. Once again, as we talked about, our gypsum kind of looks like white powder, but that's what we use. Plaster of Paris, largely made up of just gypsum. Talc powder, using it for baby powder, etc. But these are things that we tend to get out of quarries. Just dig it out and can make use of it. The next picture shows you a quarry when it's done. Once we've taken out all the good rock that we can find that has the best quality, we tend to just abandon the quarry and we're left typically with a lake at the bottom. Remember, this is just solid rock. It's not porous. Therefore, the water just collects in it, and most quarries tend to have lakes in them after the fact. Then we get to our solar evaporation. Solar evaporation. This is where we just take seawater, plain old ocean water. Ocean water is about 2.7% sodium chloride, and we just pump it into a big pond. So we just get a large area, fill it fairly shallow with seawater, and let the water cycle do its thing. The sun comes along, evaporates it until the salt begins to crystallize. And this is where we get our halite or rock salt. So this is just a piece of rock salt that we get, depending on how it kind of catches alike. When it breaks open, the backside rubs down, but yep, salty. Just this. All we do is we crush it up, where we get our Morton salt from. Or you go to the store and you get the fancy Himalayan pink salt. You can get sea salt, plain old Morton salt. It's all sodium chloride. What makes the Himalayan pink salt pink? Rust. It has traces of ferrous oxide in it, plain old rust, but some of those minerals, etc., in it are what they taunt as being nice quality. So we do need various minerals in our diet, etc. Nothing against the Himalayan pink salt, but it's really nothing more than sodium chloride, which is you're going to get from this, sea salt, etc. But anyway, pump out the seawater into it and let it crystallize. Once it gets about a 25% solution, a lot of the water is evaporated, it begins to sit in solution. Remember, a saturated solution, no more of the mineral will dissolve. So normally salt water is about 2.7%. When it gets up to 25, we start seeing salt stay at the bottom. So once I get to a fully saturated solution, of course it's hard to see in here, but down in the bottom the salt just sits there. So now we can just scoop it off. Once I get to a saturated solution, no more of the salt will evaporate. That's what we're after. We just keep going to a layer thickness. You pull that salt out, let it continue to evaporate, and keep pulling salt off. About 30% of the world's salt supply happens this way. But there's a bit of a trick to it. You have to be where it works. Remember when we talked about the biomes, the chaparral, the Mediterranean style climate? This is where we tend to do it. So all around the Mediterranean Sea has a good climate for it, but so does the areas of San Francisco. San Francisco Bay is a big area for it. Australia has some sections of this. It has to be fairly arid, and it can't rain a lot. So we can't really do that here in Florida. We'd have our big areas of the open salt, the sun would be doing its thing, and then we'd get a classic summer shower, and our pools would fill back up. But we'd never be able to collect the salt. So we only do this in areas where it's fairly arid and it doesn't rain much. Once again, chaparral climates, typically the Mediterranean, some areas Australia, and California work for this pretty well. The next picture just shows people actually in this. You see them just scooping up the areas of the salt. Then they can collect that up, clean it up, process it, and you and I are using that as our sea salt. And then we get to placer mining. I will set up a demo for this. I'll post a video a little later with it to give you an idea for it, but placer deposits. It says that they've been concentrated by mechanical action. Almost always this mechanical action is water. There's a stream. So we have a deposit of gold upstream somewhere in the rock. Well, it rains and it washes little bits of that gold into the stream and it carries it down until the stream levels out. So right here, the stream's running down the mountain, the gold's coming down by gravity, the water is carrying it, and it hits this pool and then it flows on down. Well, right here, I find gold deposits. So we'll do placer mining. This is the old movie. My dad made me watch every old Western known to man, but they'd be out there placer mining, panning for gold. Oh, found a nugget. Yeah, placer mining. You're just going where the mechanical action, typically water, has put deposits of gold, copper, silver, diamond, emerald, ruby, whatever it is. Somewhere in the mountain is the mother lode, but little bits of it break off and wash out and come down into the stream. And we can they're concentrated, so we can go dig in and find what we're after. Once again, I'll do a quick demo of that and post it up here later of what placer mining looks like. We also can find this along coastlines. Once again, water action. The tides are areas where water's flowing through, and I'll get it placed here. If I tend to have a current always coming through here, I get a little deep area, things wash into it, stay there, and the water carries on, and I'll have placer deposits. I just tend to find more of it here than anywhere else. I can find a little bit up along, but they will keep getting flushed down into this little pit or pool. So could be wave action, could be streams, etc. Gold, diamonds, any kind of heavy minerals, including like salt, can happen this way. Now, instead of it just being a dude, once again, this was the old school coal mining, just chipping it out, or the placer mining, going in and sifting my pan in the stream. Now we just have huge barges. So we just have a picture like a shop vac on an enormous sail, sucking out dirt, and it's just dumping it onto the back of a barge. So we're pulling all this dirt out, putting it onto the back of a barge, the barge goes off, and then people are sorting through it. Or machines, it depends on what we're looking for, and they're sorting through all this dirt and silt to pull out the good stuff, whatever it is we're after. These heavy minerals will get separated out, and then the sediments just drift on back downstream. Of course, the downside of this environmentally is we're just disrupting the stream. We're digging up all this dirt and muck and pulling out these big, so all downstream for miles and miles away, and now the stream is all dirty, cloudy, mucky. So you have a river house downstream, they start a mining operation upstream, the property value just went down because now you're looking for the next year, decade, it being a muddy, icky river instead of a nice clear one, which is when you bought it. So Then we're going to go to smelting. So we get this stuff. So now I have my ore, I have copper. But what happens is I've got something like this. Like I say, I'm after the pink part. In this case, it's great. Like 60% is pink, very little is the gray, the black, etc. But I have to refine it. I got to get rid of all that black and gray. So we take it to a smelter. We grind it up into a dust or a dirt, toss it into a big furnace, oven, if you will, and we melt it down. Now, we know the melting temperature of whatever it is we're after. The melting point of gold is different than the melting point of silver, is different from iron, different from tungsten, and yes, even rock itself will melt. But most rock, magma, lava, most rock itself won't melt until degrees of like 3,500, 4,000 degrees Celsius, incredibly hot, where gold may melt more like around 900 degrees Celsius. So we raise it up to the temperature that the gold melts, and then the gold melts and we can pull the gold off. But this is the idea. We are trying to get rid of the impurities. Now typically what we'll do is we wind up getting slag. We get this other stuff. We melt it down, we get our gold, but we get other things. Well, to try and get a higher priority, we throw in some stuff that we call flux. Now flux varies because it depends on the mine that we're at, what we're after. But we'll throw something in that will bond with the impurities. So the impurities gather onto that, cling to it, and then the molten metal sinks down into the bottom. So the flux and the impurities are less dense, gold very dense if we're talking gold. Gold melts, it sinks down to the bottom. The slag and the impurities float up top so we can drain off the gold from the bottom. We can drain off the slag and then try and get rid of it. So it's all a matter of the smelter is simply used to try and refine our metal to get highest quality as we can. The next slide just shows you a classic blast furnace where you put everything in, you heat it up. We can pull the slag out, the molten metal out. We're just going after the highest concentration of gold, copper, silver, whatever it is, as we can get. And then it comes to undersea mining. Well, our world is like 72% ocean. Obviously, most of the ground out there, surface, is under the ocean. So there's huge deposits of gold, rubies, diamonds, silver, copper, you name it, salt, obviously, that sit out there under the ocean. The problem is getting to it. If it's real close to shore, sure, we can do some dredging to get to it, but most of the ocean we can't dredge. It's too deep. Our ships, our submarines can only go like 1,000 meters deep, something like this. Yeah, where most of the ocean is a mile or more deep. We just can't get to it. So we've made some attempts to do it. Yes, the minerals are there, the gold is there, the copper is there. It's simply not cost effective. It costs us more money to get it than the stuff is worth. However, if you come up with a way to effectively mine the oceans, kick Mr. Pettit a little bit back because you will become a trillionaire overnight. Lots of materials there, no real way to get to it. Well, that is it for mineral exploration and mining. Take care, guys, and we will see you next time.